Hello guys, welcome back to Root and Route. Today I would like to share one of the recent adversary simulations I performed based on a real threat intel information. And the funny part, or the exciting part, was I completely wipe coded the entire flow from the beginning to end. All the codes were given by the AI, but even though it was AI, initially it was really not so good to be to work with the famous models that you already know. There are so many guardrails placed on all the new latest models, so it was a bit difficult to play with that. So I did use some other ways, and yeah, some of the parts that you can easily bypass the guardrails. Like if you change, I don't ask for give me code for some reversals or C2 code, something. It will never give you that, but still we can ask it in a different way. That's what I did. And I did use one of my local the models I downloaded locally, and I did use that for majority of the coding part, and some of the parts were suggested by some other models. So it was a mix of local model plus the other online models. But the core part was I was able to perform the entire workflow just by the assistance of AI. It was not an agentic workflow, but it was just direct chat with your models. That's it. So before moving into this one, the most, I mean, as the title says, it was a QUIC-based multi-stage shellcode via .NET. The .NET part was actually my part. Like I had to do that using .NET. The actual simulation was a bit interesting. How it worked was a malware that downloads an encrypted shellcode, and that encrypted shellcode is given to the malware. The malware then decrypts the shellcode in memory, and that shellcode is downloading another shellcode from a remote server. That is actually the QUIC agent that is controlling, that is connecting back to the QUIC controller. If you get confused, I will show you how it works, so it will be easier for you to understand that. When you just imagine that when you read this kind of stuff initially, you will also get confused. Why so many kind of shell codes coming in between, so many kind of injection techniques that the malware is using. So we could have just omitted it, but we decided to do the entire workflow. So the next challenge was QUIC-based C2 development. That was a bit challenging part, because normally everybody, when people think about the C2 protocols, it could be UDP, TCP, or it could be a bit more application layer, HTTP, HTTPS. So this one was different, and on that, because it was using QUIC as a protocol. That's the main reason we decided to have a check, because we never had this chance of QUIC-based C2 analysis before. So that's the entire story behind this, and let's go directly to the QUIC part. If you are not familiar with QUIC, it's a modern transport layer network protocol developed by Google, and it's mainly designed to improve the performance of connection-oriented web applications, and it's the core of HTTP3. And why it is, the reasons why it is attractive for function developers are the same reasons that is attractive for attackers. And one of the main reasons is its built-in encryption and security it is providing, and the performance of using QUIC. These are the same reasons that attackers started using this one as a communication protocol for their C2. So coming back to this, the wipe-coded simulation, it involved so many steps, and the main goal was to replicate the entire behavior of the malware as closely as possible, and we did exactly how the malware did on each step. So, and believe me, the AI suggested me the languages to use and the tools to use to replicate all this entire workflow. So it suggested me Go as the QUIC server and controller implementation, because Go has very stable library for that. And it again, I mean, the next step, it suggested me that even though if you are using Go, you have to do as it's not a normal way of doing stuff. I had to convert the Go to an archive file instead of a direct DLL, and it gave me all the reasons for that, why I should do that instead of converting that to DLL, and everything was just the instructions that given by the AI. So the first thing, it gave me an agent and controller server in Go, and to test it and just to ensure that it works fine. Even it was not a normal, not just for the sake of functioning. It was not like that. It gave me a fully functional agent and controller, so the controller could completely, or what to say, there was an exit function that actually shocked me. The exit function was perfect enough to close the connection from the agent and controller and let the controller work without any issue behind the scene after connecting the active agent. It was a complete set of fully functional agent and controller in Go given by the AI. Then it helped me. The next step it told me to do was converting this to archive format and expose a method. That was for another template. Actually, this output of this stage is for the stage 3, in fact. So the stage 3, there was a DLL, C++ DLL template that imports and calls exposed Go method, and this DLL acts as a bridge between the shellcode and the Go QUIC agent. You may get confused on when I'm talking about this one, but yeah, let me show this. And this involved multiple stages. Apart from this built-in template, actually it helped me to create two different templates. One for the first stager, one for the QUIC agent shellcode. The second one for the first stager that was downloading the shellcode from the remote machine. So the stage 5 is the second DLL, as I mentioned. It downloads the remotely hosted QUIC agent shellcode and executes it in memory. And not only that, the other surprising part was it gave me some C# code that before converting to shellcode, just to ensure that these DLLs are working fine. It gave me a complete C# code in different format. One was hard coding a path inside the C# file. The second one was accepting command line parameters from, accepting command line parameters as the path of DLL and the method to call, and just ensure that the DLL is working before we convert to the shellcode. I will show all the projects that it created for me, and and the final one was the exact malware behavior. The malware was using RC4 encryption, and it was a malware that has encryption and decryption facility. The same malware could be used for encrypting a shellcode, and the same encrypted shellcode could be used supplied to the malware for decrypting and doing the process injection. And the malware was using the core behavior of the malware was not that much so advanced. It was using a DLL that is supplied as a command line parameter to find a process that is the DLL is using, and it inject into that process using the create thread, and it decrypts encrypted shellcode in memory. It's just a normal process. But the main thing was like the QUIC agent shellcode, how it is getting the shellcode. So if I say so many theories about this, you won't understand. Maybe you will get confused. So I will show you all the projects that the AI gave me and the code, how I did work on that. First, this one was the first agent and server code for for the QUIC for testing. So the first thing that AI suggested me was to create the agent and run the server and ensure the connectivity. So I will do the same step here. I'm just going to build the agent from this code. So it is going to build Windows binary file for me, and if you want to see the script, it is just Windows 64-bit binary from here. And okay, after this it suggested me to test with the server. So here I have the QUIC server, and so the next step from suggestion from the agent was to test this with the in a Windows machine. So for testing that one, I'm just copying this agent.exe to my Windows shared folder, and I'm coming here and just trying to run this. Let's see how, it works. Till now it was working perfectly. So I'm just running this agent.exe. You can see it on here, right side. I just implemented only one function here. It just grabs a user information. It is not the normal the stuff that you see. There's no process opening on the other side. It just uses Windows API. I will show you the agent code. So just is use some basic Windows options to get the user info. There's nothing fancy like opening cmd.exe or doing any other command, nothing like that. So that's another thing that the AI was suggesting these things when I explained the malware behavior. It was suggesting do these kind of stuffs to do the real kind of simulation. So the first step is done. It works fine. So the next step is, see, it was a clean exit. This was another thing that shocked me. See, still the server is listening. Server has no issue, and the exit was very clean. The second step is converting this agent. Once if you confirm that is working, so convert this to a format for the Go archive. For that, you have to do this export command, and the method you need to export, and it gave me the entire stuff inside this one, and just converted the entire agent code to do the same action. So what's the benefit of this one is, there were some issues on the Linux side to build it. So I just did take here, it is here in this one, the CPP workflow, and this was the QUIC agent DLL part. I already created one. I'm just removing this one. So if you see the build back here, you can see that the build mode is C archive, and the output is an .af file, and it's going to create a header file too. So just run this. It should be so it's creating an archive file, .af file, and header file. So once it's done, yeah, it's finished. So now I got two files, one .a file and one .h file. And A gave me clear instructions on why I had to do this way other than creating a direct conversion of DLLs. I'm not going deeper into those kind of things, why it suggested that. But believe me, it had its own reasons to suggest me this one. So the next step, if we have these .a and .header file, the next project it gave me this one. And this one is a C++ template. And here what I should do is, the main thing I have to do is, I'm just using the QUIC. I have to include this QUIC archive here. For that, I have to copy the QUIC archive. All these steps were suggested by the way. So I just followed it. What should I do? Then I had to, yeah, I already did this one, but just replacing with a new one. And yeah, after copying that one, I can include it here. So it's on my local path. So the next step was here. If you see, you can see a health check function. This health check function was here that we are exposing from the Go. So when it's going to be converted to a DLL, this DLL, I mean the C++ path can call this function, and we are exposing another method here that is just calling the function inside the archive. So in the main header file, we are doing this one. And if you know C++, you know why we are doing all these things, right? All these things are suggested by the AI. So yeah, even some of the stuffs were new to me, but not these things, but other stuffs like QUIC conversions and other stuffs, Go archive and converting it to this way. These were completely new to me. I never did this before, this simulation. So the next thing you have to do is you have to do some more options here. You have to add your the .a file here for the linker settings, because you need to link that file for building it. So it's very simple. You just add here and come up here and just say add. Just say, I mean, I have already added here. So it just let me ensure that the path is correct. C++ for and QUIC agent. Yeah, source, it's the same path. So there won't be any issues for building it. So I'm just using the release mode, and that's it. That's it for building this. Now you just build it. You will have, if everything goes fine, you can have one DLL file that is having the QUIC agent. So yeah, it is here, bin release, this path is here. Just keep this path here, and now I have to show you another project that it suggested me. That was this one. This one was another project. Why it suggested it is a DLL. I mean, it's a C# project, and it is basically for loading the DLL. So before converting to shellcode, the AI was suggesting me that before converting to shellcode, you have to verify the DLL that is working. So here, how it works is, just DLL and just enter. We need the DLL path and the method name. So you just give the DLL path here and quick. What was the method? Don't get confused here. The method here is run health. It is not the other method. The other method is health check that was exposed from the Go library. Here inside this DLL, the method is run check, run health. So if this is correct, actually what I'm saying is exactly the way the AI suggested me how to check it. So if this is, if this DLL is working fine, then you will get a connection back here. So just run it and see, it works perfectly and everything is working fine, and just exiting it. So now you can convert this DLL to shellcode. So that's what it suggested me. So now we verified that the DLL is working and the function expose is working. So the next step is just converting this back to shellcode. For that, I'm just and for converting the shellcode, doing it in Windows is a bit difficult because the donut was, I mean, if you if you already work with the donut is kind of a blacklisted binary. So if you work in Windows, it is pretty difficult. Every time the defender will catch you and just remove it. So I just use this version, Linux version for that, and even this one is suggested by that, so I just followed it. So here the donut version is there. This is a version, and it gave me a build. Let me remove the QUIC agent bin here. It gave me a build shellcode script that just accept the DLL name and the method name, and this is the command that we are using. It is creating shellcode for 64-bit, and this is DLL name you have to supply, and you have to mention the method name. Then it will actually, this path is I use this path because I shared this path with my host and this Linux. So that is the thing that is going to work here. So before that, I need the DLL here. So let me copy. I think I can directly copy it from here. This one, where was the DLL? So this is the DLL. So I'm just copying it. And if I come here on the simulation, there was a file here. This file is here. So I have to copy what was the DLL name? I had to copy the DLL name to here. So the next step we are going to do is we are going to make the shellcode. And one more thing you have to do is you have to change the ownership of this one. So now I'm going to run the shellcode creation DLL and now method name. Method name was this one. So if everything goes fine, now we tested the DLL, we tested the function. First we tested the exe, normal exe that is working perfectly. Then we converted the exe to a Go archive, then converted that to a C++ DLL. Then we are now converting that to shellcode. So we tested every. We need to give an output file name. Just say QUIC agent dot bin. See, it did create the shellcode for me, and it did write to the bin file. I mean, in this folder. Why I did write it here is I had to copy it back here. I will show you. I will tell you why. But for testing this one again, I had to go back to my Windows machine. Now I have one agent, quick agent bin here. That is the result of this DLL. That means we converted this DLL to a shellcode. So the other project that AA suggested me was this one. Go to QUIC simulation, the C# workflow, the shellcode. Yeah, this was the other project. And here, the name is shellcode. Oops. Oh, I didn't check. I think it is not checking the parameter index. So I remember it was the shellcode path I had to supply. So I'm going to give the path for this one. The path of that one was file to this one. This is the path. And QUIC. So if the shellcode is fine without any issues, we will get the connection back here also. So just test it. See, the shellcode itself is working. So what the steps that we did was we converted, no, it had multiple steps. The steps that we did were, what was the first step? We created an exe, we converted the exe to Go archive, we then converted that to C++ DLL, and we exposed a method, and we converted that DLL to a shellcode. And every step we tested with different template, different binaries, and everything is working fine. See here, we got the same thing and we just tested it. Now the first shellcode is working. So the next thing we can do is, because the first shellcode stuff is working here, we completely tested it. So what I can do is I can just take it back here. If I check here, there is no QUIC agent.bin here. So I'm just copying it back to here because I had to share this file. I mean, this is going to be my file server for this, the second downloader shellcode. So I'm just copying it here. SF QUIC-Based.bin to here. I'm going to change the ownership. Now the first part is done. We created the agent and we converted the agent from the binary to DLL, Go archive to DLL, DLL to shellcode. So the shellcode is working fine, perfectly okay. So the next part of the project was, I mean, the malware behavior was so the next part of the malware was, I forgot, what was that? Yeah, the downloader. Yeah, the downloader part. So the first part we did test, we converted that to shellcode. And believe me, all these projects were given by the AI. I just did very minimal coding changes on this one. Just for, yeah, I mean, very minimal means very minimal. I didn't involve any of the AI suggested stuff. Surprisingly, this time it was very minimal effort from my side to do some very minimal, just correct some codes. So the second part was another project that was on the CPP workflow, and it was a quick loader. The quick loader is another project. So here also we have to convert this to DLL, and then we have to test it. So here what basically it is doing is it's just downloading. The quick load is the expose method. So this is downloading the shellcode, and it's doing very basic stuff, create thread, and so these processes are very, very normal for, I don't know why the malware was doing that, but this one was very normal process if you check any malware. So the next step is converting this to DLL. For that, just check the build options and linker settings. We have to add this WinInit for building this one, because we are using WinInit.h here. So just add that, and that's it. You just build it. And this entire template is suggested by I didn't do any coding in this. I just, when I faced some building issue, I just asked what to do, then it did. So it's all done, I think. Yeah, let me check it. The AI was giving me instructions on how to build, and where to add what options, all those stuffs. So just release and see. I have quickloader.exe. Let me delete all this and build it again. Yeah, now it's a lattice file. So now I'm copying this one and C++ workflow, QUIC simulation, and again back to here. This is now before that, just ensure that it's working fine. So to check it working fine, we have to do one more step here. I'm just coming here, I'm running my Python server just for testing this one, 8443. Why? Because I have the QUIC agent.bin here in the same folder, so it will be fine. It will reach here, and for testing the DLL. So here in this step, we are testing the DLL, the first DLL. The loader DLL is going to load the shell code from the remote machine and run it on the victim machine. So we're testing that. I already shown how to test that. It was on the C# workflow. C# workflow DLL with params, and it was here. So let me run this, and the path for this one, I will give this path. QUICLoader.dl. And what was the expose method? The expose method was quick load. And come back here. So how this is different from the previous one. Previous one, we directly tested the shellcode, the QUIC agent shellcode. Now we are using a DLL to load this shellcode and run it on the victim machine. So just try that. So it is finding a method and is called and connected, and it works perfectly. So we tested the second DLL also. Now we can we can confirm that we can convert this DLL to a shellcode. So now I come here, I'm going to copy quick loader .dll. I think that's a name I gave. Yeah, quick loader.dll to here and change the ownership. Now I can convert the quick loader.dll, and I have to give the method name. Method name was quick load. Quick load is the method name, and I'm going to say quick loader.bin. Just converting this. So now we convert the second loader DLL also to a shellcode file. So the next step is we have to test the shellcode, two shellcodes. So till now we were testing, we did test the other shellcode also. So we are going to do the same thing. Now this is one of the very close step to the malware. So the malware is, I will show you the exact malware, how it was working. So before that, I can't show you the entire stuff because the real malware was using a DLL injection technique that will break my entire recording if I do that. So I will show you how it encrypts files, not the complete one. But now we have two shellcodes. That was the first one was a QUIC agent, and the second one was a loader. So we are going to test with the AI gave me another, as I already shown you, or the AI gave me another C# shellcode testing file. As a binary. Means it gave me the code. I built it, but so for testing this one, the same thing. We just shellcode exe and the path to the quick loader. So this one what is doing, but if you run this one, it will fail here because I'm not running my server here. So I have to share my file. Means when this shellcode is going to run, it is going to download my second shellcode. So you can see the code here. It is going to run load and run my second shellcode here. So that's going to happen. If this is working, actually this is the exact way the malware was working. The first shellcode was loaded by a binary like this, and that shellcode was downloading another shellcode and running the QUIC agent and connecting back to the server. So let us test that. If this is working, everything is working perfectly. See, this was completely wipe coded, and my intervention was very, I didn't change any logic or anything in this one. I just asked the AI when I face building issues and other stuff, nothing else. Everything was given by the agent. It is working perfectly without any issue. Just see, just executing that. So I will show you now. This is the primary part of how the shellcode, two multi-stage shellcoding injection happened. Like the first shellcode downloaded the second shellcode of the QUIC agent and it run in memory. So I will show you the exact malware thing that was there. This was the real malware stuff that we did. So I can't show, as I said, I can't show you the exact injection technique, because after injection, it may affect my entire coding. So that's why how it is doing the injection is I'll show you the parameters of this one. So it needs a DLL and the bin file, means the first loader one, and the secret means it's an encrypted shellcode, so you have to give the encrypted shellcode password for that. So it just find out which process is using this DLL or any DLL that you are supplying, and it just inject that into that process and run this first shellcode. Then this first shellcode takes the remotely reach the second shellcode, just like we did. The only difference here is it's just encrypting and decrypting in memory. That's the only difference. Apart from that, everything else is same. No other difference. But I will show you how. And this real malware has another function. It's called encrypt. It helps you to encrypt your shellcode by using its own functions. I can show you that, because that is no. Encrypt and the input file, output file, and the secret. So the input file, it's here. QUIC loader.bin, and the output I'm just saving it here itself. Encrypted loader.bin, and I can say you can give any password for this one. Just say secret. Oh man! See, now this one created one encrypted loader.bin. So this is the only difference, the main difference that the normal shellcode loader I showed you just before this one and this one. So this one doing a bit more very noisy stuff that injects, finds DLL that is used by any process, then inject into that process memory, and then the first shellcode downloads the second shellcode. Apart from that, everything else is same. So this is how, I just wanted to show and tell that how AI is moving or helping offensive security, how it is moving, how it is reducing the time. Definitely, if I was given this task without AI, I would have taken days, maybe weeks to finish the entire workflow. Just imagine we have to, I got amazed on the processes that AI suggested me, like create a binary, then convert that to Go archive, then convert that to C++ DLL. Then it gave me another C# project to test the DLL and confirm that before before converting to shellcode, you had how to confirm your DLL is working. Then it helped me to convert that to shellcode. Then it gave me a normal binary that helped me to ensure that the shellcode is working. So in every step, it gave me not only one the normal output, but it was suggesting me what should I do to do the closer simulations. Like every step, it was giving me different projects of loading the DLLs, testing the DLL before conversion, then testing the binary and testing the shellcode itself. Then the actual simulation of RC4 encryption and how to do the injecting into some process finding the DLLs that is using the process. All those stuffs actually, it was given by the AI itself. So it's totally, again, I'm saying it was not an easy task to just go and ask the AI and AI is giving you the result. No, it was not like that. You have to convince the AI that we had to just, I know it is happening everywhere. If I could do this, that means, I just use my experience also, like how how to talk with the AI in a different way. But believe me, I did struggle with the guardrails of modern AI stuff that normally we use. Then and then I downloaded this model, and this helped me a lot in this one. Actually, it helped me 80% of this one. All the suggestions, coded stuffs were given by this. And this is running in my local machine. I didn't use any other online chatbots. I just used this one. And yeah, this was a fantastic journey for me, that AI, and I'm just wondering how AI is changing. And I would like to hear from you, like how your adversary simulations or reference security controlled simulations, AI is changing, like how it is helping you. Just comment on the video and let us share these kind of threat intel information and how AI is changing the offensive security world. So that's all for this video. See you soon with another video.